think I'll start. Welcome, everyone, online and here. We are in the product service system session and digital twin. So it was a mixed up sessions of systems engineering, digital twin and product service systems at some points related with each other. So um, today in the morning we had more the systems engineering part, and now we're going to have some presentations on product service systems and on digital twin. I will start by presenting the work that me and some more researchers have been done in the product service system working group in the scope of the industrial ontologies foundry. And then, yeah, we can go on to the others. Okay, so just a little bit of, I'm going to talk just a little bit about the history, what we mean with product service system, and what are we talking about. Show you the main terms that we have been developing up to now, what's been the progress, the status, and what we want to go on from now. So if you were in the morning in the where Dimitris and Serum were talking in the keynote speakers, they were talking about the start of the IOF. We started talking about product service system ontologies a little bit before that, together with the Falcon project. So Falcon and Diversity were two projects more or less on the same area. So they're building product service systems for industry, industry that had already some product development, and we're looking to introduce services also in their products. And so we kind of realized at some point that we were working on the same topics and each developing an ontology on their own. And so we kind of came together. So we came together. So Dimitris Kiritsis was in the Falcon project, and he kind of brought us to. So we were looking how also to put some emphasis on interoperability, and he was like, okay, I know. I think he had started already the work with Barry on the product lifecycle ontology, and so we kind of started using the BFO as a top level ontology, and it was then natural when the IOF started that we continue discussion also with in other industrial areas. And yeah, so it's been from the beginning on working within the IOF. So Falcon and Diversity, like I said, they were some use cases extending their machines. So we had, for instance, in Diversity, shoe machine producer who were extending these shoe machines with services, and we built a platform to help in the design of these machines, but accompanying these machines up to the end, so where they were in the people that buy these shoe machines, and a little bit furthermore on accompanying also the product that was being done by these machines. So getting also the feedback not only from the production line and from everybody, all the stakeholders in the product life cycle, or in the PSS life cycle, but up to the end on when we have also some feedback from the users, So it was a nice experience. It's, as you can imagine, it was a bit hard to get some feedback on people wearing some Nike shoes and going over social media and seeing what they are saying about the shoes so that we can feed it back to the shoe machines. But we modeled all this, the supply chain and all the product and services involved and stakeholders, and try that. In Falcon, we had, for instance, white and brown goods services being designed and developed. Sorry, I think I did something wrong. No. Okay. So just to put the scope on the product service system group, working group, we aim to create a basis ontology to engineering product service systems in manufacturing, modeling everything, all the aspects from product services, infrastructure, stakeholders, and everything that and all the relationships that might affect this product service system. So also, I put there also the definition of product service system at that we consider. So it's a system which aims to satisfy the need of a market. So it's something that needs to be sold in order to provide profit. So it's not something that we do just because we do it, because there is some need in the market. And yeah, and what it needs to do. So I put also there the main entities that we talk about, because we consider that the product service system, it has to contain at least one product, one service, and that is related to this product, of course, and it may include also stakeholders and infrastructure. So you kind of model the whole thing around it. So in these years working on the product service system ontology, we guided ourselves with these use cases that we had started it. We have also in the meanwhile got some other use cases from other companies that we work with. So we have, besides this product, shoe machine product extension, we have also, what's it called? Service development in the automotive industry. So when building at least a part of the car, what's all involved, and we took special attention in the information, knowledge, and data flow that we have there. I haven't put here all the entities that are currently on the PSS ontology. So we have over 70 entities and 2 object properties. I'm talking just the things that we have modeled within the product service system, because actually we are building on the IOF core. So what we see there, the main entities, the gray ones are the ones from the IOF core, the yellow ones from the PSS ontology. And as you can see, some of our main entities are also some entities that are actually defined in the IOF core. So yeah, so we, okay, from a product service system, we have the commercial service specification, the infrastructure, the stakeholders, the material products. What I was talking about, the stakeholders can give feedback on the PSS, and this is PSS in information. We also model knowledge and data being just whatever is coming out of the machine, but it has no context at all. Building up on that, we have PSS information and even more PSS knowledge when we model things like, or when we want to know things like, does my company have the necessary knowledge to build this product or this service, or to actually do the let's say the maintenance service on this machine? So this is something that some of the competency questions that we need to answer, and that we try to model there. For instance, yeah, infrastructure, we consider hardware infrastructure and software infrastructure. I'm coming to the next point, that is we found some overlapping with some other reference ontologies in the IOF core. So let me talk a little bit of what we discussed in the last few months and the issues that we encountered. So, okay, so in PSS, we are always talking about the commercial service. And this is okay because it's something that is to be sold or provided to fulfill the need of a customer. But shouldn't we also have in the IOF core generic services being modeled? And so we had a couple of discussions within our group on what could be the definition of a services or a non-commercial service, and this would be something that we need to scale up and go to the IOF core and see if this is really something that we need to model also in the IOF core. Also, something that we need to model within the PSS ontology that we found that we need to have is our resources. And this is something that only exists as material resources, but we also see that immaterial resources, so the information that you need to build a certain product service system, this is also something that we consider as a resource. And then our question would be, and this is still not answered, should we just model all resources as roles, so that we say a certain machine is a resource, or a piece of information is a resource, because anything could be theoretically. So
resource is a role.
Sorry?
It's already a role.
Yeah, it is, but you still have material resources.
Right.
So another thing that we have been talking in the last few months is, and having a use case in mind that we are planning to apply the product services ontology soon, is so we have just product, or now material product. It fits quite well with what we think about what a product is, but we think we need to extend this to also be able to model product and service variants and their families. So this is something that we are talking about and considering with together with the Pronto ontology, which is actually product ontology, and this is modeled there. We are talking with them and seeing how we can combine both, or do something there. Okay. Also some discussions on relationships. So we have to model some things that are not on the IOF or VFO. And we also started some discussion on life cycle of products, of services, and of PSS, because there's lots of work on products and a life cycle of products and life cycle of services, not really much on that we could find on PSS. So, but we haven't come further on this. I heard the presentation this morning from Jinji, and they are talking about life cycles of systems in the systems engineering working group. So I think we need to talk with them about this. So what's to be done? We have to continue working on this, on the PSS all file. It's still a little bit chaotic. We are trying to take in the IOF for better release and lining also with the new annotation guidelines and all the discussions that we had. I put there that we would like to have a better version on release up to the end of the year, but I think that's a bit too optimistic. But let's see. And I just to say about this, the use case that I was telling about that we want to apply the PSS ontology on. It's one of the OntoCommons demonstrator, and they are building, designing, setting up, configuring, and management large yard systems. And this is something that they do. Okay, they use. They have their own taxonomies and their own software and everything, and it somehow works. But there are lots of modeling of products variants. Each yard is a little bit different, but not that much. So maybe they want to use also the rules on how to build the elements on a yard. So they have some, I don't know the names, some gates that go to the weighing machines and whatnot, and there are some rules associated with it, and for this we need to model the world, how it all fits. So we are starting to use the PSS ontology to do this. The next step would be also to use the supply chain reference ontology, because they also need to model all the supply chain around everything that comes in this yard. And yeah, I think that's it. Hopefully up to the end of the year, beginning of next one, we have something to show for. And that's it. Questions? That was fast.
So I saw you have the product service system as a subclass of the system, but not engineer system. Is there a reason for not a subclass of engineer system?
Yeah, we had quite a lot of discussion on that. There was something on the definition that I can't now tell you about, but it didn't quite fit. I have to come back to you on that. I'm sorry.
No problem.
Okay. I have a question from Oliver Stoll. Is the PSS ontology also derived from literature or only from the use cases? Are these merged? Yeah, we were taking a look at the literature. There was some work on product service systems, even a paper describing everything that was around the product service. I think it was from Cranfield University, quite an extensive work that we took in, and that together with the work that Falcon had done also from literature, and together with the use cases, this is how we came to refine the PSS ontology that we have now. And how is the group planning to transfer it to academia and industry? So, on the one side, we are in the IOF, so we are hoping that this will carry also the some weight on that and revisibility that We can have the product service system being used by industry at large. And yeah, like I said, we are on our side applying it in this one demonstrator in Auto Commons. So let's see how we go from there. I don't know if I answered. Okay. I don't see anything else. We need this as soon as possible. Yeah, very good. Very good. Yeah, drop me an email. I don't know. Do you have any questions?
How many defined class do you have? Do you know? Or,
Not at the moment.
No.
We're still most of them have just natural language definitions. We don't have still semi-formal language natural language definitions. We don't have that many defined classes, so this is something we need to work on.
Okay.
Yeah. Okay. If we don't have anything else, then I would kindly ask Fabiana and Judita. They are to step in and present product service system in industry. They are both researcher and professors in the University of Bergamo. The floor is yours.
Before we continue, thanks, Anna.
Okay.
So, first of all, thank you very much for the invitation, Anna. The aim of this presentation is, to give you an insight about product service system, even from a research point of view and industry perspective. So as Anna was saying, me and Fabiana, we are a professor at the University of Bergamo, and we are working since 2006, 2007 on the concept of product service system, and we were involved in the diversity project. So why it's so relevant today to speak about product service system? Definitely because among all the different trends we have with a more technological perspective, servitization has been and has been one of the main trends that industry are and were facing in the concept of Industry 4.0. So most of the companies today are speaking about providing remote services, remote maintenance, contract-based services. With sometimes not a real understanding of what this really means for them in order to properly implement this kind of service. What we have seen in the last, let's say, 20 years of research and also industrial application in this in the scope of servitization and product service system has been, we move from the concept of product to the concept of solution, and this definitely was forced by two main trends: servitization and digitalization. Servitization that definitely forced the company in order to move from a product-centered perspective towards what we were speaking about, so product service system. So the provision of not just my product, but the provision of a solution. So where it doesn't really matter what is a good or what is a service, but what I'm providing to my customer is this concept of solution. From the other side, digitalization, as also in this case, is a business model, has pushed the company towards this concept of solution. Now, today, what we are seeing is this concept of smart solution, where companies try to sell to the customer value, which is a combination of product, service, technologies as a bundle. So the customer most of the time don't even perceive which is the tangible or the intangible part of the solution. Which are the expected benefits of applying and providing product service system? Why for the company is so relevant today to move towards this provision? Definitely, we have economic benefits. Service have a higher profitability and support the company in have a higher stability of revenues along the entire cycle of the product life cycle. In addition, providing product service systems support a better to be more competitive, because today in some industry, services are the main area of differentiation. So the technology is almost the same, the product is almost the same. So the company try to differentiate their offering only on with service and with different, let's say, combination of service. It's able to lock in the customer and to be able to better answer to new customer needs that change really constantly. So company needs to find a way on how to be proactive in order to answer to these needs. And last but not least, the concept of product service system was founded and is still quite related to the concept of being environmental friendly. I mean, as you can imagine, services are intangible, so they work towards the concept of dematerialization. In addition, if with the new concept of service, of advanced service, there is, a common interest between the provider and the customer to extend the life cycle of the product, because service can still provide profitability, but I don't need to sell a new product. If we see what is happening within the company, we have reported here some data from a survey from 2020. As you can see from the graph, basically most of the company, let's say, are far away from a real, let's say, sell and provision of a product service system in the more advanced sense. So most of the company, they technology, but still they don't see the offering as a solution, but just a product with some add-on in terms of service. But we see that we are having companies that are moving in order to think about the solution in terms of pay per and outcome-based contracts. So the industry is moving even quite rapidly towards this concept of solution. Really few companies today are, let's say, really have a comprehensive view of this concept of providing value to the customer, collaborating within an ecosystem. This is also due to the fact that providing service is still quite complex, and also thinking an ontology for product service system we have seen in the last year is not so easy due to the intangibility aspect coming with this concept. What is happening in terms of evolution? Obviously, one of the main drivers we have seen is the concept of technology, which is pushing, let's say, the company towards providing different service. You can see in terms, for example, for the car industry, the move to be mobility supplier. Think about the car to go of Mercedes and to provide the intelligent car with different service connected. The next step is to enlarge the perspective of the solution. So the solution won't be working just in a customer-supplier relationship, but we need to think about the solution within a more complex ecosystem. And here is where an ontology became fundamental, because when we have a lot of different actors that must somehow talk together, the ontology becomes fundamental in our perspective. What about research? Just a highlight, the concept of servitization and product service system goes back to 1999. We have a strong evolution of the concept. The two main, sorry, what's happened? No, no, am I fine?
All
Sorry.
fine.
No, ok. No, perché non mi va avanti?
All fine.
Vai. Sorry, okay, I have a problem. Yes, go ahead. One of the main change was related to the concept of digitalization. So 7 years ago, we start to link the concept of service to the concept of digitalization. And in the same years, we start to work also on European project where basically this work comes from, as Anna was reporting. So around the 2014, 2015, there are also these big steps. And so we start also to enlarge the concept towards this area. Today, when we speak about product service system, the number of concepts around are quite a lot. So we speak about smart service, smart PSS, product service 4.0, service engineering, cyber-physical PSS, and digital servitization. So there is a lot of noise around this concept. And the main research stream, as you can see from this slide, this is the synthesis of state-of-the-art performed last year. One of the main research stream, this also goes to answer to the Oliver question, is about the concept of knowledge management along the life cycle, where also the concept of ontology belongs. So in this area, we still have a lot of work to be done, even from a research point of view. Please.
Okay, so but what is the real state of implementation application of product service system in industry? So we have seen from literature that one of the main concepts is related to smart PSS. And we can find a lot of definition related to smart PSS, but all these definition have some commonality. So all these definition define smart PSS as something related to IT-driven or digital solution that is based on a smart product or connected product, intelligent product, with the objective to meet the customer needs and provide a sustainable value. And which are the main trends of PSS in industry? So we can see here two main trends related to technology. And the first one is the use of Internet of Things to monitor, to collect data from the product when they are used in order to know the performance of the product and to see if everything, to know the health status of the product. And the other trend is related to the so-called everything as a service. So the service offered based on a cloud-based platform. And these two technologies are the core of the solution that I'm going to present of two use cases. So the first use case that I'm going to present is related to SME, that is a large company located in Italy that produce bottling plants and packaging machines. So which was the objective of the company? The objective of the company was to improve the value that is offered to the customer, moving from a pure product-oriented perspective towards a more service-oriented perspective. Indeed, this company is used to sell the machine, so the product to the customer, and provide maintenance intervention only based on customer request, customer call. So when the product has some problem, has some failure, so the customer called the company and the company intervene to fix the problem. So the company use a structured methodology and come up with a solution that is based to an IoT cloud-based platform that is able to collect data from the machine that are at the customer side, and is able also to provide information about product performance, product health status, combining both real-time data and more static data coming from the company ERP. And we can see here an example, a screenshot of the platform in which we have some data related to each machine, data related to the performance, but also maintenance-related data. And which are the functionalities, the PSS functionality that can be provided, can be enabled by this solution? These functionalities can be divided in service-oriented functionalities and internal, let's say, internal functionalities. Regarding the service-oriented, first of all, the company is able to monitor the product to understand the health status of the product. So the platform enable the provision of preventive maintenance, condition-based or predictive maintenance. Allow the company to understand which is the cause of a failure. So help the company to make a diagnosis of the failure, but also allow the company to better schedule the maintenance intervention, because the companies can because the company knows when a maintenance threshold is approaching. While from internal point of view, we have the possibility to improve the product design, because analyzing all the data related to the install base, the company is able to understand which are the main failure, which are the main problems that happen during the use phase of the product that can improve the design of the product. But also from marketing point of view, the company is able to better profile the customer and then offer more customized, more personalized service solution. The other case is related to a medium company, again an Italian company that produce commercial dishwasher and fryers.
2 minutes.
Yeah, finishing. So this is more complex because we have distributors in the middle. So the company does not sell directly to the end user, but are the distributor that sell the product. In this case, the solution was based to a cloud-based platform that support the distributor in service delivery, and also is able to collect data from the machine. So here, an example of the architecture. So we have here the platform that gather all the data, and the distributor can be supported by the information contained in the platform, because there are all the information related to previous maintenance intervention, all the information related to product, so technical parameters, setup parameters, and then the distributor is able to better provide maintenance service, have a better knowledge of the install base, and so on and so forth. But also in this case, as previously, also the company can benefit, because it can have more information, more visibility on the product. that are sold to the end user. So we have seen different two cases, and as we can see, there are still example of product related services. So the company still sell the product and then offer service on top of this product. And then the journey towards the more advanced service is still long. And different are the challenges that company has to face to become a PSS provider that can be summarized in these six areas of operations, delivery, product design, relationship, communication, and marketing challenges. So this is all, and thank you for listening us.
Thank you. Do we have questions? No. Let me maybe ask you one. These two products or these two use cases that you have presented, are they using ontologies? No.
Not at all. They are very far from using ontology.
Okay.
But maybe they can help.
Maybe. I think some of the challenges that we posted there maybe could be at least, I don't know, communication challenges could be overcome by using the same language all over the supply chain. Yeah, so. Somebody else? No? Thank you so much.
Thank you.
Thank you.
Now wait, there is a question from a participant online. If that's okay, I will invite him to stage, Oliver Stoll, so he will be able to talk.
Sure.
Okay, so Oliver, I've sent you an invitation you should be able to speak. Oliver, can you hear us? You should be able to speak now, so you can ask your question.
You're mute?
Now we can hear you, yes. Now, yes, try now,
Okay,
Oliver.
wonderful. Yeah. Thank you. Hi, Judith, Fabiana. Thank you very much for the wonderful presentation. I was quite interested in your slide where you showed the different similar concepts to PSS, such as cyber physical systems, smart services, etc. And also digital servitization or smart product service systems. There are a lot of terms popping up by researchers and academia in order to, let's say, boost the novelty of their work rather than really connecting it to original work and original terms, which in my literature review made it very, very hard to search for specific knowledge. And I would wish from ontology that we can go in a direction where we can connect knowledge through using commonly agreed terms. And specifically to the question to Fabiana is why you chose to call it smart services.
Okay, sorry, I was muted. Because the idea at the beginning was okay, it's not just digital, so it's not just something that we can deliver through some digital tools, but this is also something that is let's say in smart intelligence. So we provide these services based on some analysis of data, based on some analytics. So it's not just okay, I provide you the services through IoT. For example, I just monitored the number of the number of hours that the machine is used, but it's something more advanced. So towards, for example, condition-based monitoring, condition-based maintenance, predictive maintenance. So it's something that is more, let's say, intelligent. And this is why we decide to go for a smart PSS.
Okay, that what you call smart PSS, would that fit into use and outcome-oriented types of PSS according to the definition of Tucker?
Yes, because when you sell an outcome, you sell a result, you have to be sure that your machine and your product is working properly. So you have to try to anticipate failure, have to try to maximize the performance, the efficiency, effectiveness of your product. So in this case, analytics, artificial intelligence can help to prevent failures and to maximize the productivity.
Okay, thank you very much. Thank you for letting me ask my
Thank
question
you.
in person. Wonderful work. Thank you.
Thank you.
Thank you. So we go on to some digital twin presentations, and I believe Dan Isaacs should be online, but I don't see it. Luigi, do you know?
He is currently not online. I'm contacting him by email, so we can try to go to the next.
Yeah, if Michel Sauvage is here. Yes. Okay, either we connect everything there. Yeah, okay.
Unfortunately, I cannot share my presentation.
Okay.
Strange corporate rules.
Okay.
Sorry for that.
No. Do you have the HDMI? So?
Is it full?
Connect online.
Non, mais on ne peut pas faire trop ce genre de manip avec nos PC. C'est compliqué. Donc, ce qu'on va
And
faire,
the
c'est
speaker.
que... So sorry.
Yeah.
Yes, for the speaker, yes, for
Yeah.
sure. Mais non, non, je ne suis pas connecté à cette application. Donc, ils ne vont pas m'entendre.
Ok.
Ce qu'il faut juste faire, c'est pour qu'ils voient l'écran.
Okay. Good.
Can you see the screen? Sorry for the difficulty. We have strange corporate rules in Airbus, so I cannot share the PDF. So I'm a colleague of Rebecca from this morning. I'm part of DDMS. So DDMS is a transformation project at the company level. And I am in charge of the definition of the architecture framework for the company to support the transformation. But today we'll talk about digital twin and ontology. So just say caution that for sure Airbus is very big. Okay, we are a lot of people with a lot of good idea. So here I just want to share with you one experience. It's not the voice of Airbus, but just to share an experience with you. Okay. The second point is I strongly believe in ontology. I don't want to anticipate a little the conclusion, so I'm a very promoter on the ontology. I introduced ontology 7 years ago in the digitization of the data inside the engineering, so I'm a big fan of that. But for some time we have some issue, and this is what I will share with you today. So when we are talking about digital twin, we are talking about individuals, so really physical aircraft. And in the proposition of the example we have here, we are talking about a fleet, so a set of aircraft for a set of company. Okay, so it's a lot of different data, and the data comes from directly the airline with their own MRO, so system of maintenance. the aircraft, and we would like also to connect the different elements from engineering, manufacturing that detail what happens of the aircraft. Okay, this is what we want more. And the idea is, if we want to have this kind of data, representation of data, or everything are connected, for sure, an ontology is really a good candidate to be a neutral layer to be able to connect the different information that come from different database, for sure, with different technology, different data model, different representation, and so on. So the point is how we can do that with ontology. So our experience is to create an ontology, and this is also very important, to connect the ontology to the data. It's really a huge work. Okay, and our experience today is that when it is a topic of a subject, we want to tackle a problem. It's something which is possible, that requires specific skills, because today, unfortunately, on the market, few people are really able to organize workshops, to deal with different people, stakeholders, and to be able to capture the knowledge and to formalize that with an ontology. And we have difficulty in terms of recruiting those people and use those people. Okay? So it's very helpful for alignment, but we need specifics. For a domain, it's relevant for a domain, but it should be small domains. Because after we have really, we have to take care about all the different people, and we have to train them to be able to read the ontology. Because it's nice to create an ontology, but we have to validate the ontology by the business. So that means we have to work also with the business to say, guys, is it conform to your business, to your activity, to your knowledge? And in this case, when we have a domain, it's something which sometimes it's hard, but it's possible. Now, if we come back to our problem with a several set of database from external and internal of the company, unfortunately today, we have a kind of, I would say, limitation in terms of scaling. This is a difficulty we have today. We made some calculation and we say, if we want to converge with different airlines and different domains inside Airbus, and sometimes just inside Airbus, we see that it's just impossible in terms of effort. We made some calculation and we are talking about a decade. So we say, okay, it's not possible. So the question is what we can do. And we have the idea and we test it to use a control vocabulary. So here we have a very nice example. We are not expert on that, but according to, I would say, my departments, I can see a thrust system, a motor block, an engine, and an engine assembly. And the point is how all those people could work together. And what we propose is to create a kind of mechanism thanks to tagging and thanks to control vocabulary that people are allowed to describe their own structure according to that domain. So here we have the service domain, the assembly domain, the product structure, and the functional domain. And by some tagging and relationship in between, we are able to reconnect those data together and to have a kind of digital thread. So the question now is how to create this vocabulary. So for that, we use this standard, RDS, and this is a standard that comes from industry about battlements, building. And we reuse exactly the same idea, and we have created with some subject matter expert a long list of terms, which is official terms. And to give you an idea, we have several catalog, and to describe an aircraft from a physical point of view. So if I just come back here, do you have an idea of how many words we need to describe an aircraft? Just in terms of class. Do you have an idea? It's 900. So it's not so big, because now go to the domains. For a domain, we made an analysis that if you want to describe, for example, a wing, because you are an expert of the wing, it's less 100 terms. And we check with some psychologue and some, I would say, from social science, that if a human could tackle 100 words, and it's possible. Because with the words, we have a tag, and it's after some training, say tag 1, tag 2, and tag 3. So it's able to, so it's manageable. Yes?
Are those the leaves of the hierarchy or everything from top to bottom?
It's in between.
Oh, okay.
So the dictionary structure with chapter.
Yeah.
We have chapter with 1 letter, chapter with 2 letters, or chapter with 3 letters, but each element are leaf level. Okay, but it is organized. Yes. And to give you an example, a very tangible example, so we have some tools and bolts, okay? And for sure inside Airbus, you know the story. So we have some program with ramp up and some program is not the same situation. And the question is that it is possible to reuse some tools from one final assembly line, from one program to another program. In other words, do we have some tools which is not aircraft dependent? So that means you can reuse from one file to another one. Unfortunately, today, according to our say, information system, we are not able to make a query and say, okay, I need some tools which is not program relevant or program impossible. So what we did, we create the tag and we ask people to tag. And here you have the number of tags which is generated for people for this number of bolts and this number of tools. And it took 2 months with 3 people. Okay? So it's not so big. It's something which is possible. Okay? And after, when everything is tagged, with some matching, you can easily say, we are talking about the same tools. Okay.
Is it okay to ask questions?
Yes, yes.
So I've done similar efforts on oil and gas facilities, which are, I think there's similarities and the differences. I'm just wondering, how happy are you that you know what your types of bolts and your types of tools are? How much do you, how high quality are your classes for these, your tool types and your bolt types? Is it you're using historical, the tag's already there, so you already had a tag format for them with the tag values and stuff?
The key point was to explain to the subject matter expert, because at the end, this is an end user that tags the content, to understand how the content is organized. And what we did, we created a specific UI to facilitate the life of the tagger. So that means the person that, and say very comfortable about 1 hour. It's okay, I understand how it's organized, I understand the structure. I don't care about the 900 different classes. I care only about that, and it is already filtered by the UI. And guy is very, very comfortable to tag. So it's not a fantastic job to do, but when it's done one time, after you are able to tackle this kind of thing.
But I think I'm asking a slightly different question.
Sorry.
Is that how sure are you that the SMEs types are high quality? Because what we found at least in oil and gas installations is that, particularly if they're old, I imagine some of these aircraft might be, just all recent, not old, but you get a real variety of tag types and.
We checked that after on the field, and the first feedback loop was very, very good, because at the end we asked to use this tool and to say, oh yes, it's a good one. So the quality was very good. So we are confident about the ability of the guy to tag correctly to think.
Okay, one more question?
Yeah,
so
sure.
Is I think that's good and that's impressive compared with the oil and gas assets, which are really, really bad. But it's the type. So let's say this was a round bolt and a square hole, and you had a square bolt with a round top and a triangular hole. Is that there's different levels of quality? So did you make any assessment of the quality of the types for the bolts and for the tools? So I mean, for instance, what we found quite often is that you have these 6 different tool types, and when you look carefully, there are actually only 3. But people know their names, so that if your people, they're used to the site, they'll say, oh yes, I know what this is, but the actual typing is not good.
Sometimes also we use picture to facilitate the selection. But I could ask the question. Send me an email. I will put you in contact with the guys that really monitor that. Monitors at the field. I don't want to say stupid things.
Okay.
Just one more question about that. To be clear, the tags are even following the methodology of ISO 18206.
In fact, we work with the company that promoted this language to create our own dictionary.
The Danish company?
Yes. Okay. Yes. So we work on them, and we would like to promote, and this is the proposition we had today. Today we call that ACL, and it's at the beginning it was Airbus Common Language, but now we would like to say Aeronautic Common Language. Okay? And we would like to push that as a standard, not to say it is an Airbus one, we don't care about that. It should be a standard recognized by the market for other companies to facilitate the usage, also with our partners. So the idea is we have several steps of data, We continue for sure to have ontology as a domain layer, which is really important. So we continue to believe on ontology, okay? But after, according to the size and the scalability of the issue, what we propose is to have here something which is common, a standard one, ISO, okay, which is common that could be used internally and externally. And we have put some mechanism to say, according to now of this domain ontology, we are able to map to this one, which is based on the standard. So the idea is we have created a mechanism internally to say now, according to this dictionary, which is a standard one, which is recognized by the market, we are able to map our domain ontology to this one. So that means in this case, we can connect several ontology, which is locally described, because if we come back to this story, we don't believe that, imagine here we're talking about different company. We don't believe that we are able to say to our partners or suppliers, we have to talk the same language. We forget that. It's ridiculous. Everyone has his own language, his own topic, his own information system. What we promote is to say, guys, work together to have a contrary based on the standard, something which is a vocabulary. And we have also created classes, but also relationship. Okay? And after, each one make a mapping to this, I would say, control vocabulary, and that means in this case we can connect it. So for sure, the tagging will not cover every kind of use case we can do with ontology. It's something which is complementary.
Can I just check? I've just been looking at the standard. So presumably you're tagging, I don't know, if I use the term function location, does that make any sense? Okay. So if you're tagging the function location, you're not tagging the actual bolt itself. Yeah, is that right?
No, because in fact, in the information system, the location is already done. So what we want is just to say, sorry, I don't want to touch your bottle. Don't touch mine. For this program, we have this kind of tools.
Yeah.
In this program, we have this kind of tools.
Yeah.
Unfortunately, the coding and the description, and we have no clue to say, are they the same? We have no clue to make some matching. To say, are we talking about the same or are they different? So what we propose is to put some tagging, say, you are an expert on this program and this kind of toolings, could you put some tag from an official catalog? And we ask you to another subject matter expert, could do the same thing? And after, for sure, we can say, yes, it is the same.
I think I'm asking something slightly different. So it's if you imagine you have a car and you have the front right wheel of the car, yeah? And then you change the wheel 5 times. You have 5 tires with 5 serial numbers. Are you tagging the 5 tires, or are you tagging the position of the wheel?
No, we are talking about an individuals, so the 5.
But in 81346, they talk about having a part of relation. So your part of relation will change, because that wheel could be taken off this car and put in another car, or maybe you don't keep track of the part.
No, we are talking at the individual's level.
Okay, and you're not doing a breakdown talk on this. Okay, I understand. Okay, thank you.
Nevertheless, we have some relationship to create breakdown. But in the case I share with you, this one is just at, I would say, object level. We are looking for just this kind of thing. And what we have also, because after it's very easy, is to put all the documentation which is related to how to perform this kind of task and so on. And thanks to the graph, I would say, graph representation.
Yes, I totally agree with the approach. It's quite very interesting. But just to, part 1 of the ACBT 346 is about the methodology and breakdown structures according to different aspects. And this is a key concept.
No, you have to
Function,
wrap it up.
Yes.
Okay.
And
Done.
part
1-2
2
minutes.
is about
Perfect.
the composition.
Which is a conclusion.
Is about the classification. And we will go back to part 10, export product system, power systems. Yes.
But I think you have a problem with replaceable parts, so that you've got from an ontological point of view, in one case you've got 5 tires, in the other case you've got 1 tire, and you need to have an infrastructure to the replaceable parts. So if you've done the individuals, We can't do a
You can
breakdown of some
talk
of the
about it.
ingredients.
It's very interesting, but
Okay.
So just
yeah.
thank you. Just to finish. So we continue and we still believe strongly in ontology, but for problem solving. Okay, it's very, very important. And if we have some teacher here from these nice schools, please train your students about how to read ontology and how to author ontology. Thank you. Because we have really, really a big issue on the market, okay, on this point, okay? And don't train people to create requirements, but more model. This is another story. Also, what we discover, it's I like the idea that we have ontology and we are able to use it to understand the data when we know how the data are organized in the database, and where we are able to distinguish how the database is organized from how it is used by the end user, because sometimes we have a big gap. So this is also a big issue. And we have the operating models, because if we want to ask to a company to say, guy, please now you are a steward, you are a data officer, whatever, and you have to well describe your own data, it's something you have to organize. At the scale of the company like Airbus, it's not in this way. So what we propose is tagging with control vocabulary I explained. And the idea is to be complementary, because we know that a tagging system will not cover the same kind of, I would say, use case we can do with ontology. The idea is not to say it's better, no, it's just complementary, okay? And what is interesting that it is like an ontology, this is a data which is operable by human and machine, which is good. We can do that thanks to the standardization with internal and external, and we are working hard to create this thing at ISO system. And this is today, we made a demonstration that we are able to have a massive tag solution to facilitate the thing for the end user. Thank you very much.
Thank you. So we had already questions and discussions between, but please, Mara.
Okay, no, just a quick question. So you are tagging instance of the vocabulary, not the models or documents or things. You are tagging the real object.
For the moment, yes.
Okay.
The purpose is to tag models also, and to
Okay,
tag
and
artifacts
then-
inside the model.
And you are using controlled vocabulary that was defined like a standardized, or is not, you have not provided your own vocabulary, I mean Airbus vocabulary.
Yeah, yes, we have created our own vocabulary to describe. So here, all the subjects, I would say, are Airbus vocabulary.
Okay.
And this is something we have some exchange with Boeing, and say, guys, do you recognize that? And say, oh, yes, it's my business. So it's not a specific Airbus one.
Okay.
You know,
and do you have the upper part of this taxonomy?
what do you mean by?
What are these objects when you connect? Do you have some connection to several other classes or not?
Yes.
Or
because
everything is a thing?
No. And this is what I would say the big trouble. It's to be able to connect the domain ontology with this vocabulary. We need to align. Are we talking about class? Are we talking about an individual? What is a tuple? Which kind of tuples? Blah blah blah. So we perform a lot of things also to have pattern to say, that looks like a process, or it's kind of block from an architecture point of view. So we have created also a set of patterns to facilitate, I would say, the connection, and to secure that when you describe an ontology here, it should be naturally, I would say, linked with the upper level. So we have to do that.
Very good. It's funny how we step the same step with the same class of problems. We are not creative at all.
Which is a good news or bad news? I don't know.
Yeah, when you need some solution quickly,
Yeah.
just the same way.
Okay.
Lots more questions.
We don't have time. Sorry. you can continue discussion afterwards. But I'm not a very good time management person, and we are already late. Sorry.
You're very generous. Yeah, it's a good trait. Generosity is a positive thing.
Thank you so much.
Because he's no longer generous in the coffee break.
That's probably a bad thing.
Thank you.
You are better than me when I am the head of the session. Just throw away the document. The discussion is too interesting. Better not try.
Tell me which one.
14.
14? This one? Okay. Ah. Yep. Now it's Francesco Zaccarini. He is a researcher in University of Bologna, and he's going to talk a little bit about the work from between Auto Commons and product services.
Yeah. Good afternoon, everyone. Greetings if you are in another time zone. It's a real pleasure to be here. I'm Francesco Zaccarini from the University of Bologna. Today, I will talk about what will be going on in the product and service focus area in Auto Commons for package free. I have to clarify that I'm not a domain expert in the product and service area. My talk will be mostly about methodological points concerning bridge concept. Bridge concept will be presented more extensively tomorrow. So I'll try to give some reference points both on the Commons framework, general framework, the OSS, the ecosystem, and on bridge concepts. Most of you will have been present yesterday at Professor Scarey talk. So I want to dwell on the OSS and how it works, but I'll try to go over it again because it is really important to understand the context of bridge concept and how they are employed. As for bridge concept, I can only give a few pointers today. Hopefully there will be enough to follow the discussion. So the Commons bridge, the Commons ecosystem is a network of harmonized and interconnected ontologies revolving around the NMMVP area, hinged on pluralism and fairness.
I'm sorry, I think I didn't share the screen.
Oh, sorry.
Yeah, I'm sorry. I'm sorry.
I can continue what. The general idea is to focus on a certain value chain in the NMDMP area and follow it to all the process. When I talk about pluralism, it is from the very top because it is founded on three top-level ontologies: BFO, Dolce, and Demo, and partial mappings among them. The partial mappings are really one of the most important points of this general of this ecosystem. Is it? How can I go full screen? Sorry.
Okay.
Yeah, it's not a problem if it is not full screen.
No. This is the wrong one.
But in the meanwhile, the partial mappings have been done in first order logic, and then they have been employed to create some mappings in our to the. The mappings are really important because they are the ground which allows for are the backbone of the at the core of the ecosystem, and they are what really makes it possible to have bridges which are validated, and they also help in engineering bridge concept. So another characteristic of the ecosystem.
You need to swap screens at the top.
No, there it's the correct one.
Oh, okay.
Oh.
They have the correct one and we don't, but it's okay.
Just don't look on the right side.
Cheats,
Yeah. But I want to be able to. If you want me, I can read it. It would be a better presentation, I can assure you. So that aside, well, that's just the general gist of the Onto Commons ecosystem. We have 3 top-level ontologies. They are interconnected via strong mappings. And then we have bridge concepts. Bridge concepts are what really makes it possible to have more interconnection inside the whole ecosystem at different levels, because what is the connection at the top level cannot guarantee all the connections which are really needed to have interoperability. Moving on, if you want to have a general idea of the framework, you can find it on GitHub. The repository is there if you are really interested. It is a work in progress, and then at the moment there are only the top-level ontologies, a few mid-level ontologies. We are still working on deciding which domain-level ontologies will be included. And again, the ecosystem is open, so if anyone wants to join and want to be enlarged in the future, that's possible. Even for new top-level ontologies, but that would mean that there will be a need to generate more top-level mappings at the top level, which is a bit more difficult than simply adding a mid-level or domain level on top. Now let's move on to bridge concept. Bridge concepts. So they are one of the tools which is being developed by the Commons Consortium in order to achieve our goals and realize those. At first, you can think of them as standalone ontological entities. So they have no formal characterization when they are engineered. They're engineered following a principle of having some point of reference for the users and stakeholders. So we need to create something which is connected to the standards and as a hub and spoke structure as a connection to them. So we don't simply take 1 or 2 standards and say, okay, our bridge concept, our concept we are defining is can be compared with them. No, we consider all the standards which can be employed by users and stakeholders and can shape their concepts, the concepts they are using. And we try to create explicit connections between our bridge concept and those standards. They are documented and the rationale is explained, and they are very extensive, but the user can only focus on what is really interesting for them. As for selecting which bridge concepts are to be created, the general idea is to focus both on what ontologies need to have the proper connection. So there is a network analysis starting from ontologies which are considered from the field, and there are questions, the user thinks, and to have something which is something the user at the end users can directly work with. Because one of the real problems with top-level ontologies is that the concepts are not the ones which are employed by domain-level ontologies and by demonstrators. So once the bridge concepts are created and connected then to top-level ontologies, then it is as if there is an expansion, downward expansion of the top-level ontologies, granting a direct access to users and stakeholders. The way they work in a formal way, given this connection, is that you have both hierarchical and equivalence class relations between the bridge concept and the top level and the middle level, domain level, application level ontologies. So there is a double hub and spoke structure, both in the formal characterization of the concept and in the formal characterization of the concept. That will really make it possible to employ bridge concept in a really affordable way, because scalability is an issue. The 2 roles they can then play, given their position in the network, etc., is spreading downwards reasoning and enabling data sharing at the core network positions. This is an example of the templates which are used to create and engineer the bridge concept. There are parts for different stakeholders, and they are ready for implementations. obviously, looking at it like that, it might be a bit overwhelming or even unelegant. But once we get into how bridge concepts are really employed and which parts are for which person, it might become a bit more clear what's the real idea behind that. Again, when it comes to the elucidation of the concept, it is really important to notice that we are employing a double standard. What do I mean? The concept is elucidated in a way which gives a general idea to connect to the person for the user. We are basically employing an idea of fit rather than match to connect to the user to the concept of the user. The user is a domain expert, so they will understand what we are generally even pointing to. Afterwards, there is a part which is dedicated to eliminating the possible and misunderstandings. So that's for ontological use. That eliminates possible misuses of the concepts and which create a lot of problems when it comes to alignment and interoperability. So getting to the product and service focus area, it is quite a particular, peculiar area because there are many substantial changes. And it is possible to see how bridge concept can be really employed in this case, even if it is not the general use of bridge concept, but in this peculiar case, there are more benefits to having bridge concept. Servicification of the transaction focus and servitization of firms is one of the elements which destabilizes the conceptual landscape. The same can be said about eco-manufacturing, the sustainability, or well, their new societal interest which destabilized and made new concepts start being used inside the conceptual landscape. And digitalization, because digitalization is not just digitalization in general, but comes with many side effects such as new policies and laws and everything like that. So the result is a liquid and disunified and rapidly shifting conceptual landscape. Again, conceptual variance is a given in any context. But in this case, it is very different because while usually it is well, in everyday communication, you don't really have standard concept employed by one. It is again a thing of fit rather than match communication. Communication is a thing of fit rather than match, and there are no monolithical concepts out there. But there are no real points of attrition unless we are focusing on borderline cases. That's not the case when the conceptual landscape is being reshaped. So that's something that infiltrates even standards. So for instance, this is a famous example of standards which are apparently jointly inconsistent. So ISO 9000 and ISO 1440. They have different definition of products which are, on the face of it, completely inconsistent. And users which focus on them and employ them to create their own concept and possibly create their own ontologies and use their own ontologies will obviously have difficulties because the concepts which are expressed here will provide a basis for clashes in interoperability. So the consequences for formal ontologies are self-evident. Underdeterminate ontological entities, gaps between formal and informal characterization, and specifically erroneous usage by users, which is one of the points which came up in one of the discussions this morning. It is really a critical point because if even an ontology is really well defined, etc., but the user adds to some way meddle with the ontology to try to fit its own in interest and use cases, then its operability crashes down. So data sharing and exploitation of reasoning are undermined or greatly impaired. Yeah. So there is again an exponentially growth of error, and so if the reasoning this is even more problematic. So, is it a problem that can be solved by introducing another standard? The answer is probably not. Why? Because there are benefits to pluralism. Why does a user select a certain way to speak of products and not another? Because it is useful to them in their context. Obviously, that's something which you all want to be limited, but it's even difficult to do that because to have a standard which is shared by everyone, you have to impose it. And having the strength to impose a standard is not something which is really easy to achieve. And it is even less useful to focus on labels and carry out conceptual analysis and say, okay, we have a label. What is the right concept? Because even if there is a right concept, and the one you are trying to talk to doesn't use it, you will still have a problem. So bridge concept can act as a mediator, as a compass. That's something which is connected both to all the standards and can be really clear from an ontological point of view. Obviously, the precondition is that the user reads the bridge concept and understands the bridge concept. But since we are really working on having the bridge concept connected to a lot of reference points at the same time, something that fits the needs and desiderata of stakeholders, that should be a step forward in achieving that. It can be even more useful to have a densely populated core of bridge concept when a certain domain requires it. Again, this is a remedy with, well, something you could call a grandma remedy because it is not something which you would really want as a final solution. But the point is that this also facilitates the emergence of a new equilibrium, so new concepts which are shaping the art. Some more, well, in Work Package 3, we are working on different sub areas, and we are interested in having more ontologies. It is so more than important to have a form of interoperability which is not limited to local systems and a certain group of users. We are working at the moment with PSS, which is a presentation from here, and Ponto. There are people in the panel, so I want to really developers and in the panel, so I want to really discuss some more benefits of bridge concept in this case concern cases in which inter-domain connection are required. And for the product and service focus area, it's really a matter of choosing which what to consider, because product and service are concepts which are really useful in all industry, e-commerce and sales. So bridge concept, how can they help in this case specifically? Well, their neutrality, ontology neutrality, and ontological neutrality, because we try, when possible, to avoid any ontological commitments which clash with this or that ontology. Since different domain will focus on different categorization, this is really a need for having bridges between one domain and another. To get to the last point, when top-level ontologies approach the partition of the logical space, they usually do it in a very abstract way because they focus on, well, for instance, onto-client is one of the instruments employed to have a correct partition of the logical space. It is a partition which avoids conceptual mistakes, and it's really beneficial in the creation of ontologies. But when you come down to domain and application level ontologies, some partition of the logical space which would improve conceptual clarity are not really needed. And they are even something which is an obstacle to a real implementation for demonstrators. So you have concepts which do not fall, well, concepts from application level ontologies which do not fall under any branch of a top level ontology. The solution might be to have a cluster of bridge concepts which recover some form of reasoning and allow clusters, well, allow some form of interoperability and data sharing, even in these scenarios. Again, it's not recovering the whole reasoning nor the completely harmonizing well, not allowing for full data interoperability, but it's something, and it could be a way to go forward and think whether it is possible to, achieve something. Many thanks for getting up with me, and
Thank you.
How generous are you?
Huh?
I said, how generous are you?
Yeah,
How many
it was-
questions do you have?
Anyone?
Go
I
ahead.
think I should be second. I should be first.
One by one.
Go ahead.
On slide 7, something I don't understand is that does the bridge concepts are between concepts, but what happens if you have your data you get a data set falling under exactly one to one. It looks as though you're creating almost like a new ontology that's a merged ontology in that case of A and B. Is that right?
Yeah, it isn't right, because there is a bridge concept with, well, you can think of it as a whole ontology if you consider the world models taken from an ontology and everything was called with subsumed by a certain concept they are connected to. And it is one of the points which is as a basis of the modularization of the ecosystem.
I didn't quite get that. We can talk later, but can I assume that the bridge concept is like a mapping? So if I get TLOA plus TLA data and schema, I then use the bridge concept to map it into TLOB.
Yeah, but it is a mediator of the mapping more than a mapping. And at the same time, while it is a mediator of the mapping, it might be given modularization, a mediator of a certain mapping for a certain user which needs this concept, and not a mediator of the same mapping. And that's why I didn't really go into that, because it will be presented tomorrow. But it is one of the very core points of modularization, because the user can really choose what bridge concept to employ, which ontologies to connect it to, which concepts they really need, and even avoid a lot of complexity, but it is not really avoided, it simply doesn't appear.
So what Francesco is saying, you need to go tomorrow to his talk.
I'll be on a plane, but I would try and listen remotely. I'd get someone to listen for me.
If you already try to apply this in practice, because I get in this room the concept seems like it's simplifying the world of ontologies, but I can also see how in practice people may look at this and go, there's yet another concept I need to understand. Or
That's really one problem. So we haven't really had any feedback from domain experts yet.
We're just starting now. So this is a methodology and it's Onto Commons project. I don't know if you're familiar with. We're more or less in the middle. So
then again, it's not a case of the same problem reappearing as a meta level. Why? Because while you have a lot of different standards, there are a lot of different standards. Right? There are a lot of gladiators in the arena. Adding another standard in one more gladiator in the arena. But if you have one bridge concept which is connected to all the standards and more bridge concept or concept, call it however you want, which are connected to all the principal resources in a domain knowledge appear, you will have more and more connections, and that should help to have at the end achieve the desired result. So yeah.
Thank you.
Sorry, have you thought about that when you use this rigid concept? You have a transition relation of your conceptualization, your meaning to the other model, and then if you have another bridge concept, you can do some wrongly transition.
The idea is that having a bridge concept which is both ontology neutral and ontologically neutral as much as possible should help dealing with that, if not resolve the issue. Or maybe I didn't get this question.
I really cannot understand what is ontological neutral. That for me there is a big set ontological neutral. Because there is nothing that is not ontological.
Yeah, in many cases, some choices have to be made. Let's say, for instance, I give an example, physical field, you have to decide whether you want to focus on the physical quantity or on a region of space-time. If you give priority to one or to the other, you will have different concepts in a way.
So that's your meaning of being ontological, not neutral.
Yeah.
So being neutral means that you are not providing any meaning, because it is not in the domain one, it's not with the meaning one, and it's not with the meaning two.
In that case, you have to choose. And that's one of the limits of the neutrality. There are limits to neutrality. But if you focus only on a characterization which sticks to the domain, for instance, product, is it really necessary for products, well, goods, to be a bit more clear, to be tangible? Is it really a characterization which comes from business, it is business. It is unclear. It might not be constitutive of goods to be tangible. It might be useful because if you are tangible and not intangible, you get a partition of the logical space, which is the one you want. But it's not a characterization which is based on business terms or business concepts. And that's the kind of limits, but yeah, it should help having a clear domain. Then again, I didn't really go into that, but tomorrow.
My feeling in the first moment is that you are having the right feeling about the problem, but you are not providing the right solution. That's my general feeling. That's good. But I will be there tomorrow.
Yeah, I think we can continue discussions tomorrow. It will be very fruitful. Thank you.
Many thanks.
Okay, so. Okay. Can I please? Exactly. So we have now the panel session. The person Dan Isaacs didn't appear, so I suppose he's not doing any presentation today, which fits good because we are already late for the panel. So
you can keep asking questions.
Yeah, so we have now a panel. We would like to, I would like to invite, I think Judita and Fabiana are already in. If Dragan could also join the stage, and Gabriela Henning and Marcela Vighetti from the Pronto Ontology. I think you received the link. You should have, so that you can join here and we can we'll talk about. Sebastian, do you want to you want to join the panel?
I'm here.
I think then people don't hear you.
Yeah.
Yeah, very good. So we have Dragan.
Hello.
Hello. Welcome.
Gabriela is already also there.
Yeah, they need to follow the link to join. It's not the one on.
No, she will get now invitation. I just got it, and she will.
Okay. Okay.
She was in the backstage. She's
Yeah. Very good. So I would like to, since this is a product service system, okay, a little bit on digital twins. I think then I can ask the experts here also to talk a little bit about this. But I would like to have some little discussion, if we can, or I would like to hear your opinion on the relevance of ontologies in product and services and product service systems in modern industry. So maybe you can say a few words about yourself and say something. I don't know.
I already said about myself.
Yeah, that's true. You can go ahead to saying a few words on the topic.
Yes, I mean, just maybe some additional reflection on what we were saying before about the role of ontologies in the context of product service system. Since at least from what we have seen at industrial level, when we speak about service, even if in manufacturing context, we are really far from any kind of standard. I mean, it really far away. So this means that we don't have any kind of reference model, for example, for processes, standard processes, even how data are collected, categorized within the platform. No standard, no ISO, whatever. So I think that ontologies would play a really fundamental role also to support in changing the way on how service could be designed, could be delivered. This also will force people in try to standardize a little bit some elements, which is fundamental. Also to change their perspective. Today, services are still really reactive. So someone call and I deliver service. I don't really plan things. So changing this perspective is fundamental, and I think that ontologies can support also in these things, which is not the real role of ontologies, but is something that is a must be to make ontologies really work in an industrial environment. Another quite important thing is that in my perspective, ontologies can and must work as a bridge between product and service. We know product, we already have ontology, we already have a lot of standards and whatever. To build this bridge in order also to be able to make the data from the product available to support the delivery of services is something that is definitely needed in order to provide the smart PSS we were referring about before. Last but not least is about the concept of ecosystem. I mean, we were speaking about ecosystem, supply chain in a different, along the different speech. So product service system will force to think in an ecosystem perspective. And if we don't have ontology supporting this way of working, I mean, we just create a lot of chaos, and we cannot really be profitable at the end of the day. We just react. But if we want to really build a solution with an ecosystem perspective, we definitely need to have ontology that can guide the design of this solution.
Thank you. Very, very good points. We have to work on that. Maybe we can continue with Dragan.
Okay, hello, I'm Dragan Slokic from ATB Bremen, from Institute for Applied System Technology in Bremen, and I'm with Anna, Sebastian, and Judita and Fabriana working on PSS ontology for several years. I fully agree with this, what Judita already said. Actually, a few years ago, that's about 7-8 years ago, when we started working in the scope of diversity project, we thought about, do we really need ontologies for PSS? And came already then to the decision that we needed it. Process of development of PSS is even more complex than development of product and service itself. You have this combination of product and service, and what Judita said, this complex relation between product and services makes things even more complicated, and without a clear understanding of mutual relation, it's no chance to really make this development process of PSS economically and successful and innovative. The problem at the top is that with PSS, the spectrum expertise of people who are involved in development of PSS is even wider than in development of product or services. Already in modern products, you have very wide spectrum of expertise, but with product service system, you have even wider spectrum, even broader spectrum. And to honestly say, you have this especially strong involvement of ICT people on the one side, and people from mechanical and electrical engineering on the other side, and communication already in between these people can be challenged. Most important thing for PSS are data, of course, and digital servitization, which Judith and Fabiana talked today. And this means using data is another aspect which tell us that we need good structuring of data, allowing to reuse in engineering of PSS and in service operation. Actually, we have always several use cases in mind, but generally speaking, two cases are in mind in developing PSS ontology. One is development of the PSS process of that, using data streaming from different processes around the product and service life cycle of manufacturing of products, use of products, and so on, and also the data streaming from products. On the other important use case is development of services around the product itself, using data streaming from products and their use. But there are other cases. But just to say, so there is a need for ontologies, but there are many obstacles in using ontologies in PSS. The important thing is in using ontologies not to start from the scratch and to avoid development of new ontologies. The problem is that for PSS, one needs very different ontologies, not only related to product and service, but also to processes, to materials, to environment, and so on. So reuse and combination of these existing ontologies appear to be even more difficult. And that's one of the reasons why we are so strongly interested in these bridge concepts and so on, in order to allow for easier combination and reuse of different ontologies. But to do that, you need experts in ontologies, and you don't have these experts in ontologies in manufacturing companies, for example. There are not many, especially not in smaller companies. On the other hand, efforts for development or combination of these ontologies can be quite high and need really strong involvement of experts with domain knowledge, and these experts are normally busy with other things than developing or reusing ontologies. So the question is always to find a trade-off when it really pays back to develop or reuse ontologies, and in the PSS development or development of services, and where maybe it doesn't pay back. Okay.
Yes. Thank you. Thank you so much. Maybe we can hear it now from Marcelo or Gabriela. They're both researchers involved in the ontology with whom we are now collaborating and working, and product ontology. So maybe from there we can have some thoughts.
Okay, can you hear me?
Yes, very well, thank you.
Okay, thank you, Anna. Well, I'm Gabriela Henning, I'm a professor at the University of Litoral in Santa Fe, Argentina, and I integrate a group of people. Marcela is also here from 2 research institutes from 2 different universities in Santa Fe, Argentina. Well, we have developed some time ago the Pronto ontology. It was motivated by the need of formally handling information in the manufacturing domain, but not in the discrete manufacturing domain as you are just telling right now, of products that are that have a life cycle in themselves, that they live once they are bought, like a machine. It is used and it produces information. Our motivation a long time ago was to properly handle information for doing planning activities, scheduling activities, logistic planning activities. It was manufactured. It was motivated in the consumer goods. We were working on some real cases in meat industry, candy industry, chocolate industry. So we realized the need for handling information about families of products and subfamilies. We call them variant sets and actual products. The concept of family is well known in industry because, for example, in the automobile domain, it is used to handle products in this idea of a platform of products. The same happens in the software industry, but in any processing industry, food industry, the concept of family is also used for doing planning, aggregate planning activities or planning deliveries, etc. So we wanted to have this type of information, that the information of families, subfamilies, with different aggregation degrees of the information that is handled. For example, in planning, some not real products are used to do planning activities. They are called substitute products, and they are not real products that have some sort of average information, aggregated information of all the individuals that belong to the family. So one of the main goals of Pronto was to represent that information. We call it abstraction hierarchy, and also another information that is the structural hierarchy, the one that is, for example, in industry commonly known as the bill of materials information, the recipe information, bill of chemicals information, that allows representing the composition, the assembly, or the decomposition. In the meat industry, we have slaughterhouse where cattle are disassembled. And we wanted to have a generic representation that allows to handle any kind of composition or decomposition of products components. And on top of that, what we wanted to have on Pronto is the integration of both hierarchies, because we realized at that time that there were some representations of the two things, but not integrated. The ontology was first implemented in concept base, then in OWL. It is not based on top-level ontologies. That's one of the drawbacks. Because we were thinking at the beginning on consumable products, food products, candy. It does not handle service information, stakeholders, or infrastructure as the PSS has. Also, we handle structural information, but in a quite generic way, do not include any geometrical information. Well, one can specialize the ontology to do that. And originally, we did not include the handling of changes along the life cycle of products. But that was later extended. Marcela will speak a little bit about it with the Veronto ontology. It's a versioning ontology. Regarding the life cycle of product, of course, it's quite important for services. And here, from my point of view, one has to distinguish the life cycle of the designs of products and the life cycle of the actual products, and the two of them have to be integrated. We are just starting to work with the team that is here. We have been having some meetings, starting thinking about some bridge concepts. We are at the very beginning of our work. I guess this is it. And now Marcela can share some thoughts about the versioning ontology. Thank you.
Thank you so much.
Hi everyone, my name is Marcela Vegetti. Gabriela present me. I've worked with her for many years in the development of ontology in the manufacturing domain, particularly product ontology, and also versioning ontology, which is an ontology to capture the evolution of products along time. Pronto lacks the ability to represent, control, and change management of a product, during their life cycle. Products are affected by the market, technology, and user requirement. Without a process for efficiently handling product changes, product data, which is spread in different areas and systems, may become unusable, incomplete, or inconsistent. A simple change in product information may trigger a domino effect that could be very difficult to control. In order to reduce this effect, knowledge is important to answer what, when, why, and how a change occurred on product structure. So we propose versioning ontology, or Veronto, an ontology that allows capturing product changes in order to answer these questions. This ontology is composed of 3 modules. The product history module contains the concept and relations regarding the identification of the product whose evolution is going to be captured, and the set of versions that constitute its history. The version description module comprises the concept that characterizes a particular version and allows answering what, when, why, and how a change that leads to a new version occurs. And finally, the change propagation module deals with the impact that a change event has on the element of a product structure. To the best of our knowledge, these ontologies, Veronto and Pronto, are the only ones that lead to the product variability problem, which is an important issue that face product and services related industry. In this type of industry, product life cycle management is an important activity that requires robust solutions to represent product data models, enabling information exchange across different organizations, stakeholder processes, stage in the product life cycle, and several business activities. It is widely accepted that ontologies constitute an enabling technology to support such solutions. They provide a common understanding of concepts belonging to a domain, and their formal representation make them a good candidate for the Industry 4.0 digital transformation. However, I think there is a long way to go. There's a great number of ontology related to product and services, as Dragan said before. So what is the one that fits better for my industry? If I need to use more than one ontology, can I be sure that they work well together? What is the best way to harmonize them? I think there are also some performance problems regarding scalability issues that need to be addressed. How do the ontology we test with toy examples at the laboratory level work in industry that deal with big amount of data? How the reasoning capability of our ontology affect the performance of industrial systems? I think that performance is an important aspect that prevents more widespread use of ontology in the industries, actually.
Thank you. Thank you so much. Yeah, I agree with you. There's still lots of questions in the air. Let's try to solve this with the IOF ontologies, with the ontocommons, tools, methodologies, and the main ontologies, and all the other work that we have listened here already, and that we're still going to listen tomorrow, all the experts here. So, yes.
Fabiana perhaps want to say something?
Yeah. You want to say a few words, Fabiana? I don't know if you're still online.
No. She's only listening.
Okay.
Good. Okay.
Okay, but maybe here, I don't know if Sebastian, you still want to add something to this?
Maybe 1 or 2 points. So my name is Sebastian Scholz. I'm also working for ATB and together with Anna and Dragan, and in the past also with Judita. And not much what I can add to Dragan, but if you, maybe to highlight it once again, if you have a product and you want to design this from the beginning, you need, I think, ontologies on a conceptual multidisciplinary level, because imagine you want to build a simple terminal which is built of several products. You need to talk to mechanical engineers, to software developer, embedded software developers, to high-level software developers, and all of them are using different terminology. And I think by this, ontologies can really support us closing the gap. But also then later on, if a product is deployed at the customer side, it can even support us when you send their maintenance team or teams or have to discuss with customers. So I think on this level, really ontologies can support us.
Yeah. Thank you. Some more considerations from the room?
Quiet.
Everybody wants to go to coffee break. Actually, I would like to continue discussion and also hear about the digital twin part, but it's really coffee break time before the next session, so I think we should continue with the coffee in our hands outside and get some fresh air. Thank you all. Also online. Thank you.
Thank you. Bye-bye.
Bye.
Bye.
Thank you. Bye-bye.
Bye-bye.
Thank you.
Thanks for joining.
You're welcome.
Okay, hear you next week.
See you.
Yeah, see you.
Okay, it's at